hello and welcome to YouTube. Mr. Robinson back here with another brand new exciting video. All math-based, of course. As always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. If you step on inside, guys, we are looking back in the integrated math 3 realm on solids. And last time we were in the last module, in the last review of everything we did, we were looking at the volume of solids, filling it up with water, sand, what have you, with cubic units. Well, that is, what if you wanted to put something inside it and fill it up, and what space could it occupy? Now we're going to talk about what's called the surface area. And if you imagine, guys, 3D shapes and figures like this water bottle that I have right here and stuff, it's not what can fill in that we're going to answer, it's how you can cover the outside. If you wanted to paint it, if you wanted to wrap it around with something, Christmas wrapping paper, something like that, just how much would it cover? What is its area? And it's really weird to talk about area with a three-dimensional figure, and that's exactly what we're going to be doing in such a way that we're going to be representing these two-dimensionally. That sounds weird, right? We're going to take what appears like a box. I'm looking at the first problem right now. We're going to take what appears like a box, and we are going to unfold the faces of the box and lay it out flat so we can understand what it means to collect the area, the surface area of these shapes, how much it would take to cover the outside. And it takes a little bit to kind of digest. I really do recommend that you do draw these surface areas, these what are called net drawings, to help you with it. I'm going to recommend it to my students, or I'll be drawing it out every time to kind of just preach what I practice. And from there, I think the formulas are going to make sense. So if you'll indulge me, guys, as I do these problems slowly to begin with, you'll start to understand what I mean by these formulas as we go into them. And just please follow along with the terms that I'm going to use on each of them. And after that, hopefully we can kick it into high gear and go a little faster, because this time it's going to be based on prisms and cylinders. Eventually we're going to get into pyramids and cones, and I think even spheres with them. And if we do, well, it's just going to be a little different. I think these are the easiest of them. And, we're just going to have to play with it a little bit. Just go with me here. All right, so I'm going to do, I forget if it was 8 or 10. I have the possibility of doing 10 practice problems. I think I'm just going to do 8 of them. Time and everything else, and, eventually they run their course a little bit. But here we go. Find the lateral area and surface area of each prism. Honestly, I'm focused on the surface area. Lateral area will come with it. There are a bunch of areas that I do want to find out, and, lateral is going to be one of them. So, surface area in general. What is it going to mean? It means that I got to find the area of this face right here, and this face right here, and this face right here, and the one that's underneath, and the one that's on this left side, and the one that's on the back. Got to find the area of every single face right there, add them all together, and that will give you the surface area. If you can see around the box, that is the surface of the box. Now, they talk about lateral area here as well, and there's another thing that we could be talking about, which is base areas, or bases area, because there are things called lateral faces and things called base faces for each prism that we're referring to. So here's what's going to happen, and this is going to be a little tough for you to digest because I don't really have one to kind of show you right now. You can do this with a cereal box, with your package of something that you have, but I'm going to unfold this box. Okay, I'm going to unfold this box, and I'm going to kind of give them some numbers to help you here. All right, let's call this front face right here number 1, face 1. And this one on the right, let's call it face 2. Over here on the left side, let's call it face 3. I'm going to call it in such a way, I don't know if this is going to make sense, but it's going to be written backwards. It's like if you're looking through on the other side of the box. I'm not going to do that. That's weird. Face 3. How about face 4 in the back? Sounds good. And then 5 on the top. 5 is on the top and 6 is on the bottom. Okay, 1 in the front. This is tough, right? What I'm going to do is I'm going to unfold this box. I'm going to take the top and I'm going to unfold it upward. And I'm going to take the bottom and I'm going to unfold it downward. Outward in such a way so that, check this out. If 1 was right here facing us, let's fold 5 upward so it comes up like this. Because we're going to flatten out this entire thing. 5 is unfolding upward. 6 is unfolding downward underneath it. I hope you're with me so far. This is really tough unless you take a box with yourself and make sense of this unfolding of these things as they come upward and outward. Now I'm going to take 2, the one that's on the right side of 1, and I'm going to fold this one outward. It is on the right side. It's going to stay on the right side. And 3 I'm going to fold out from the left side over here. And, we want one of these, we want 4 to be attached either to 2 or to 3. I'll have it attached to 3 just so it sequentially makes a little sense right there. 4. This is what is called, guys, a net drawing. A net drawing. Okay? A net drawing is the unfolding and flattening into a two-dimensional representation of your surfaces of your figure, of your solid, in this case a prism. And prisms will have this kind of representation of rectangular lateral faces. Remember these ones, 1, 2, 3, and 4, these are called the lateral faces right here. And then 5 and 6 is they were on top and bottom, and I'm saying that in such a way that I represented them as bases being on top and bottom. This is a base face. Base face. And this is a base face right here. Now, we're definitely not done with everything. The net drawing is just giving the representation of what it is that we need to begin with. All right. It still gets a little confusing with here. I still haven't given you a formula. And look, you can find the area of each individual one and then add them up. That's fine. But there's kind of a nice, slicker way of doing it, you know, based on what there is. And I hope that this breakdown is going to totally make sense with it, or you've probably heard it before and you're like, just get on with the problem. Well, this is my way of getting it to understand every single time after, so I can go faster once I see another prism of the same ilk. All right, it just, actually, what kind of shapes are we going to have here? All right, I think I'm going to skip number 4. Oh, well, I don't know. I might do number 4. If you know how to find areas of hexagons, I'll do number 4 with you. That's fine. All right, so let's keep going with this. So what you have here, guys, you also do have these representations. If you look at face 1, there's a length of 5 right here, 5 feet. And then its height is 3 feet right here. Now, because these are rectangles, that means all of these will be 3. This will be 3 feet. This will be 3 feet, right? There's a height of 3 everywhere. So I'm just going to put 3. So that's 3. I can't do it. I can't not put the feet. So that's 3 feet right there, 3 feet on that side. This is basically, guys, a large rectangle right here. Of all your prisms, when you unfold the lateral faces, you will get a representation of a long rectangle. How long is the rectangle? Well, we know it's as tall as the prism's height, right? 3 feet. But how long does this get here? Well, consider all the different lengths that we're looking at here. We got 5 feet going across face 1. Then we got 7 feet going across face 2. That's kind of neat. So I can say 7 feet right there. Once again, you know that that's 3. Now, faces 3 and 4. Look, this is a rectangular prism. And something we know about rectangles is opposite sides are congruent. If this is 5, so is this. That means that 4 has a 5-foot width bottom, and then 3 has a 7-foot one, because that's across from face 2 there. So that's a 7-foot width bottom. And, you know, total, we could add all these things up, and that would get the entire length right here. And I will. I'm going to add all these things up. But it's not just writing this out to add these things up that you need to do. That's not a necessity, all depending on what you know about the shape. What you can do is look at this shape and understand what happens when I add 5 with 7 with 5 with 7. Not just the numbers, not just the answer. What is that representation? Look at this right here. 1, 2, 3, 4. First of all, this is making the rectangular base, this number 6 right here. This is the outline of the base. I am adding up all the sides of the base. Do you know what that's called? That's called the perimeter. When I add the 5s and the 7s all together, I'm getting the equivalent. This thing right here, this unfolding, that is the perimeter of your base. Because see how this 5 lines up with the 6 right there? The 7 is supposed to line up with that. The 5 here is supposed to line up with that. And 7. This is the perimeter of your base. This length in your lateral faces, all unfolded, is the perimeter of your base. And this is all going to be important when I'm going to write out my formula. And then this is, of course, the height of your prism. So that's cool. That is awesome. We're going to find those things out. So let's start writing out a formula based on all the stuff I'm breaking down on problem number 1. I know I'm going almost 10 minutes to problem number 1, but I promise this is all going to help you here. So surface area of a prism comes in the form of doing the 2 following things. You got to find the lateral area, the area of the entire unfolding of all your lateral faces. You got to find the lateral area. That's what they want us to do. And you got to find the area of both of your bases too, right? You're going to add up everything. The good news is the area of one base is congruent to the area of the other base. That's how prisms work. And we've used capital B as the area of 1. If you double it up, that's what you get. So this is how you find the surface area of a prism. The surface area of a prism is the lateral area plus the area of your 2 bases. How do you find the lateral area all on its own? Well, as we noticed, it's a large rectangle, so it should be length times width. But what is that length and that width? The length is the perimeter of your base. It's the perimeter of your base. And the width, if you will, is the height of the prism. Perimeter of base times height. So it takes a little to uncover everything that we're doing there. It's a little bit, but we'll deal with it. And once you kind of have the formulas, you just kind of plug things in and you're good to go. Now, how do you find the area of the bases? It depends on the nature of the base. These bases are rectangles, so you do length times width. And make sure that you do recognize that, there's one part I haven't written out here, that would be a 7-footer right there. 5 by 7, like that. So here we go. Let's find these things. So let's start with the area of a base. That should be pretty easy. The area of a single base would be, as I said, 5 times 7. And that's going to be 35 square feet. Cool. That means that the area of two bases would, you double that. The lateral area is going to be the perimeter of the base times the height. So we got to do 5 plus 7 plus 5 plus 7, that's the perimeter of your base, times the prism's height, which is 3. So that's what we're doing, perimeter of base times height. That's going to be 24 times 3, which is 72 square feet. So we have the we have the area of a base, we have the lateral area. Let's find the entire, and they're asking us to find the lateral area. Okay, I found it. I'm going to do that each time. The surface area is the lateral area. I'm going to write this one more time. Lateral area plus the area of both bases. So that's going to be the 72 plus 2 35s. 72 plus 70 gives us 142 square feet. Now this is area, this is not volume, so it is square feet, not cubic feet. As you can tell, square feet were added there. We found the surface area of the entire thing. This is how much square footage would be needed to do whatever it is you want to do with it, including just calculate it. And the net drawing does assist you a little bit in what goes where and what you're trying to look for, and it really helps explain the formula. That's really why I wanted to make the drawing in the first place. Maybe at some point you can understand how to do one without a net drawing, but as long as I get a unique shape, I want to give that drawing at least to begin with. So triangular prism comes next. We'll do that. Now, another kind of good news thing about this, guys, is that, right now I'm talking about surface area, but I did come from volume before. It's not out of the question for some test or something I ask or whatever at some point to ask you to not only just find the surface area of your solid, but also the volume of your solid at the same time. And part of the good news is, although it's not really this wholesome thing, sometimes the information you're trying to find in one helps you find information for the other. I know we've never had to do lateral area and perimeter of base, but we have had to do area of base before. And when we get to some of the cylinders, we're gonna have to sometimes find the radius and find the area of a circle and stuff. So you're on your way to getting your answer to something within volume by using information here that we would need, right? What is the volume of this thing? It's going to be area of base times height. So it's going to be 35 times 3. I got it. It's 105 cubic feet. I already got the answer. So it's kind of nice that you can almost kill two birds with one stone just by pulling out the information and organizing it in such a way that is helpful to you. All right, about 14 minutes on one problem here. It's not guaranteed we'll go super fast in all the rest of them, but now you know what it is we're trying to do. Lateral area plus area of both bases. Lateral area is perimeter base times height, but I still want to focus on the net drawings and making sure you get what's happening there. Sorry, I hate when my thing does that. All right, number 2. Whoa. I can't explain why it does that. I have no idea. Number 2. We have this triangular prism right here. Now remember, the triangles are the bases. Those are the top and bottom that we're going to unfold from the top and bottom. They're not always drawn on the top and bottom. The rectangles are the lateral faces, right? Those are the lateral faces. So this time I'm going to use my rectangle tool. I'm just going to draw this larger rectangle as it is the unfolding of those rectangles. How many rectangles are there? Because of the triangle, the nature of the triangle having 3 sides, each edge gives you a respective face. So there are going to be 3 faces to this triangle, and I'm not drawing this to scale. I'm just giving you 3 faces here. 3 faces right here. Let's call this front one. I'm not going to call it 1 and stuff, but let's say that this front one represents this one right here. So I have a 5 centimeter width of that front face with, of course, a height of 2 centimeters all around. Let me just put it right there. And then this one on the right that unfolds outward is 3 centimeters in width like that, or in length. And then this one that folds out this way has 4 centimeters like that. See if that makes sense. This is just the rectangles. The 3 rectangles unfolded are right there. Now on top I have this triangle right here. Let's say that, as this part represents right there, if you know what I mean. I'm going to unfold this flap up and outward in such a way that now I have a triangle that's doing, this. Let me give the line tool. Triangle that's doing this right there. I unfolded it upward. So you have the equivalent of, well, this was, this is 5 centimeters here. This is 4 centimeters. This is 3 centimeters like that. All right, so there's that triangle. And then I have the downward triangle that's, underneath right there. So I have, once again, a 4 and a 3. 4 centimeters, 3 centimeters, like that. So there is your, there's your triangular prism unfolded into its net drawing equivalent. Okay, that's what you have. Now, there's information that this thing doesn't contain, and as I'm looking at it, I'm questioning what they expect you to know and what they expect you not to know. And I gotta tell you one of these things right now, guys. This triangle, these triangles right here, this 3, 4, 5, that is actually a right triangle. They didn't tell you it. I don't know if you know anything about Pythagorean triples, but a squared plus b squared equals c squared means 9 plus 16 equals 25, means that this thing actually is a right triangle. And that's important, because how else could I find this area? I need 1/2 base times height of a triangle, so I need to know what are 2 perpendicular parts. 3 and 4 are perpendicular to each other. That was actually a requirement of mine to know, right? They didn't really tell me that. So let's go ahead and work that one out here. Let's, I don't want to use black. Let's use purple. So the area of the base, once again, it's 1/2 base times height because it is a triangle. And I need to identify base and height as 3 and 4. So because they meet perpendicularly, that's kind of the idea. Half of 4 is 2. 2 times 3 is 6. So I got 6 square centimeters for a single base. The lateral area is once again going to be perimeter of base times height. It's this entire rectangle here. 4 plus 5 plus 3 represents this entire width right here, perimeter of base, times the height of the prism is 2. 4 plus 5 is 9 plus 3 is 12. 12 times 2 is 24. That's 24 square centimeters for the lateral area. So that is, they asked us for it, so there it is. The surface area is going to be the lateral area plus 2 base areas, because there are 2 congruent triangles, both the same ilk. So that's 24, let's just do this in one. 24 plus 12 is 36. 36 square centimeter surface area of that triangular prism. And one more time, excuse me, if I wanted to find, I'll write out the volume this time, guys. It's really fast. The volume of this thing is area of base times height. I have the area of the base. I found it already. It's 6. I know the height. It's 2. That is going to be 12 cubic centimeters right there. They didn't ask for it. I'm just letting you know that you are on your way to finding one if you found information, if you use the information to find the other. We didn't use lateral area for volume, but we used the area of the base, and that, took a moment to figure out with that right angle stuff. So kind of nice that you can kind of do 2 and 1, and really it's something worth practicing because you just came off of that, and you can bet you're going to be using it again. All right, number 3. This time I'm not going to do the net drawing. I want to see if we can understand what it is that we have without it. I will do a net drawing on number 4 because it's kind of out there. But on number 3, once again, it's a rectangle. Well, it's a square prism. I have a square base on bottom and top, and then I have these rectangles that would unfold. So how would these rectangles unfold, though? Remember, this goes 5 all the way around. This is 5, that's 5. This is 5, that's 5. Our surface area is lateral area plus area of both bases. All right, the area of your base, as it's a square, let's square the 5, and we get 25 square centimeters. That's good. Lateral area, once again, guys, it's perimeter of base times height of prism. The base perimeter is all 4 of these 5s here. So 5 times 4 is the perimeter, 5 plus 5 plus 5 plus 5, perimeter of your base. And then times the height of the prism. The height is 10. That's going to give you the lateral area. That's 20 times 10, which is 200 square centimeters. I probably should have written 5 plus 5 plus 5 plus 5, but I was just giving you kind of the faster version of that. All right, that's the lateral area. Your surface area is that lateral area plus your 2 bases, one on top, one on bottom, and you get 200 plus 2 times 25. 2 times 25 is 50. 200 plus 50 is 250 square centimeters. And don't get me started on how fast volume would be defined. Actually, volume is also, it's 250 cubic centimeters. That's interesting. Same volume, not really, same number, representing volume as it does surface area. Cool. All right, number 4. I was thinking about not doing this one only because I'm not talking to my students about it, but if you guys are doing some on your own with these, great. Let me show you a little bit about it. I want to go fast, give you the net drawing, and then give you the area of any sort of regular polygon here. All right, well, first of all, we have a 6-sided shape on top and bottom. That means there are 6 rectangles wrapped around. So when you unfold this thing, right, your lateral faces represent six different rectangles here. And they actually are congruent. I don't know if I'm going to be able to draw them perfectly congruent. I'm not really attempting to. I just want to have 6 of them. But they do mark up the fact that right here, you see them on top. All these are congruent. That's kind of important. I don't think I could have gotten the area without that information. But this is a regular hexagon on top and bottom. All 12 meters each. 12 meters in width here. 12, 12, 12, 12, 12, 12. So 12 meters across. Let me just do single tick marks like that to get that representation going. The height of the prism is 15 meters here. And then you have regular hexagons on top and bottom. Now I got a tool that can do that for me right here. Great. Kind of overlap with the shape there. They unfold on top and bottom. I hope you're kind of getting the gist of the unfolding practice that's going on here. Yeah, that's kind of what's happening. And then they give you this 10.39. Now this, if you're one of my students, you're not doing this problem anyway, so you're not paying attention right here. This thing is called an apothem. Apothem is the shortest distance from center of your regular polygon to any one side, which means it makes a right angle going in that direction. I think they made a right angle symbol there. So that is 10.39 meters. I'm sure they might be asking you to find this area in different ways. Maybe they want you to find the area of a small triangle. I bet that's probably what they're trying to do. Otherwise, they wouldn't mark these things here congruent. But let me give you how the area of a regular polygon works on top of, because you could find the area of this triangle and multiply by how many triangles there are, 12 of them. But here's how you'll find the area of a regular polygon. It's 1/2 apothem times perimeter. You just found out how perimeter works, and guess what? We get to use perimeter more than once here. We get to use it for lateral area as well. So let's find out the perimeter of this base. Perimeter of the base is 12 meters each times 6 sides. 12 times 6 is 72 meters. The apothem is 10.39 meters. I don't have my calculator out, so that's kind of... So the base area is going to be 1/2 10.39, which of course is approximated, times 72. I know half of 72 is 36, so I got to do 36 times 10.39. Here we go, 36 times 10.39. I'm getting 374.04. Do not round this number. They didn't tell us to. 300, oh, did I divide? Yeah, I did. Took half of it. 374.04 square centimeters. That is the area of a single base. Let me double that to be safe and know what that is when it's doubled. Times 2, 748.08. I'll have that one on the side for myself. All right, lateral area. We still need the perimeter of base times height. We know the perimeter of the base, right? It's 72. We already got that information. Like I said, I like when you can use more than one thing and you have it organized so you know where it is. Lateral area is going to be perimeter of base times height, like that. 72, 748.08. I'm going to remember that. 72 times 15. 1080. I feel like I should have known that. Lateral area is 1080 square meters. All right, here we go. Let's find that surface area now. Surface area is your lateral area plus 2 base areas, which is going to be 1080 plus 748.08. 1080 plus 748.08 is 1,828.08 square, not centimeters, square meters. That would be wrong. Square meters. That is your surface area of your hexagonal prism. All right, hexagonal prism. Yeah, there are kind of different ways you can work that out. Once again, if you found the area of a single triangle, you found out this was 6 meters here, 1/2 base times height, multiplied by 12. You can figure it out a bunch of different ways there. Kind of gave you the shorthand version, something I hope to run into in other videos I do, but not doing it with my students yet. I don't think they learned it last year, so not bothering with that. All right, so that's the first page there. That's the first 4 problems. Let's see if we dive into some cylinders now. We do. And this, and some composite figures. Great. So 7 and 8, I'll end on 7 and 8. I know there's a 9 and 10 of composite. I'm going to leave them. Time will work against me here as I'm already 25 minutes in. Let's play. Now, numbers 5 and 6, guys, these are cylinders now. They're no longer prisms, but what is a cylinder but a circular prism? I've said that before. So the volume of a prism, if you think it's not the volume, the surface area of a prism, if you think it's any different from the surface area of a cylinder, you'd be wrong. It is the lateral area plus the area of the 2 bases. And the lateral area is no different. It's still perimeter of base times height. But because we're dealing with circles, there are ways that you can write this stuff out that's kind of nicer. Like as in it's only specific to this. See, in the last one we had a rectangular prism, a square prism, a triangular prism, and a hexagonal prism, and perimeter was added. I mean, you added it up, but the area of the base was always different. It was either base times height or side squared, or 1/2 apothem times perimeter, or 1/2 base times height. Just they always change. Circles are always having an area of base. Oh, my thing kind of crashed here. Hold on a second. Oh, there we go. Circles always have an area of base that's pi r squared. And we'll talk about the lateral area as well, because there's a specific way we can write that. So, as everything appears circular to you, I do want you to know that if you unfold the lateral facing right here, and it kind of is a single facing this time, it is still a rectangle. Think of a soup can with a label on it. If you think of my water bottle right here with this label on it. If I take this label off, I don't know where the label thing is. Hold, please, as a math teacher doesn't know how to take off a label here. Yeah, the water bottle's circular, but if I take this label off, I can't really. There we go. If I take this label off, this label, guys, is a rectangle. This label, unfolded, is a rectangle. Okay? Now, I think it's important for me to show here. How long is... We know how tall it is. It's as tall as you saw it when it was on the thing. But how long is it? Well, if it goes around the reach of your object, if our object's a circle, that reach around, we don't call a perimeter for a circle. We call it a circumference. So this length right here that goes across the top or the bottom, we don't need to call it perimeter because that's not a circle. We call it the circumference. It's the circumference of your base, of your circle, on top and bottom. That's what it is. So when we're doing this right here, let's start with the unfolding. Remember, it is a rectangle that's unfolded right here. So like that, just, nice and long. We do have circles on top and bottom. I know this is kind of weird to kind of perceive as an unfolding here, but got a circle on top. Let's just copy and paste that same size and I'll have a circle on bottom. And that is your net drawing of your thing. Again, 2 bases and a lateral area that's once again a rectangle. So none of that changed. We know that the radius of this circle here is 3 feet. We know that the height of the prism is 4 feet. What we need to find is, of course, a base area with pi r squared. And then we need to find out what this length is right here. Now, I just mentioned it is your circumference of your circle. This length right here, this length is the same as this length. This thing taken and unfolded represents this whole thing right here. A circumference of a circle is 2 pi r. So the reason I wanted to mention this whole thing right here is when you find the lateral area of cylinders, you are going to be doing perimeter of base, which is circumference. Perimeter of base times height. Perimeter of base, circumference times height. Circumference of a circle is 2 pi r. 2 pi r times the height of your prism. So if you want to write the surface area, I put prism here. I did mean to write cylinder. I'm sorry. Even though, listen, they're the same thing, right? Cylinder is the same thing, but if you want a specific version of it, if you want it specifically, and this one's kind of cool to write because it if you had to like memorize it, it's check this out. It's going to be lateral area, which is 2 pi RH, plus 2 bases, 2 pi r squared. 2 pi RH plus 2 pi r squared. I'll go ahead and use that one as long as we're talking about cylinders. It is the area of both your bases, and then the perimeter base times height. But it's just kind of a nicer way to put that in. If you have access to it, you can go and use that. So let's come up with the circumference of this thing. Let's do it all. Actually, you know what? You just want to plug it in? I just said I would. Let's do that. Let's plug it all in. The surface area. They do say find the lateral area, but you know what? It's all going to be within here. Surface area is 2 pi r h plus 2 pi r squared. I think next time I'm going to do the other kind of mundane version, area-based lateral area, add them together, because in case you ever have to find the volume with it, I don't want you to, lose your work. 2 times 3, leave your answer in terms of pi. 2 times 3 is 6, times 4 is 24. So I get 24 pi here, plus 3 squared is 9, times 2 is 18. I get 18 pi here. So surface area is going to be 42 pi square feet. And there it is. This is the lateral area. This was the area of both of your bases, of both of them right there. All right. Cool. That's number 5. Let's look at number 6 now, which is, even though the circles here are on the side with the cylinder, these are still your bases. If I drew a net and unfolded it, that's what we'd be dealing with. Oh, by the way, this circumference, 2 pi r, 2 times pi times radius 3, this would have been 6 pi right there. That would have been 6 pi feet. Okay, so I'm not going to do a net drawing this time. Let's actually do area of base, and let's do lateral area, and then I'll add them up like I would, as you would just like an area of a surface area of a prism. So the radius, let's start with that. Your diameter here is 11 inches. Let's divide that by 2. And do I want to leave it? I'll call it 5.5. 5.5 inches. I know a lot of people don't like improper fractions with it, even though I'm cool with it. 5.5 inches. So let's start with area of base. That's going to be, see, now I'm going to leave this as 11 over 2. I'm going to not use the calculator if I don't have to. Area of base is going to be pi r squared, which is pi times 121 over 4, which is 121 pi over 4. That is in square inches. So see, I can do that without a calculator. I squared the 11, squared the 2. I can do that without a calculator. Leave it like that. And I like the exact format of that a little more. That's a personal thing. All right, there's the area of the base. So let's kind of pocket that one to the side. Change the color, though. I don't want it to get too blind and blue with my previous problem. All right, the lateral area. Lateral area is perimeter of base times height, or circumference, right? Perimeter of base is circumference. Perimeter of base times height is going to be 2 pi times the radius. And then this is going to be all times the height. The height is 7. 7 is the distance between your bases. That's what makes the height of the prism. So times 7. Now 2 over 2. 2 over 2 is 1. They're gone. You have 11 pi times 7. That's going to be 77 pi square inches. So I have my lateral area. I have the area of one of my bases. Let's now find the surface area by doing the lateral area plus 2 of these, pi over 4. 2 over 4 reduces to 1/2, so a 1 just kind of goes away, and you have a 2 there. I need a common denominator here, so I'm going to multiply 77 by 2 over 2, and I'm going to get 154 over 2 pi. 154 pi over 2 plus 121 pi over 2, which gets me 275. I'm getting really bad at my addition math. 275 pi over 2 square inches. There's the surface area. If you have the decimal version, guys, that should be 137.5 pi square inches, I believe. Yeah, that sounds good. Once again, when it comes to volume, you found area of base a long time ago. You can take area of base times height. You can get that volume there of that one. Just wait till we get to cones and pyramids and see how you feel with all this. All right, 2 more to do, guys. We're going to be dealing with both cylinders and prisms. Looks like they're both rectangular prisms here within and a cylinder. Now, the thing about surface area that I want to make sure that you know, unlike volume, remember when we do volume of composite figures, we add one volume with another, or we subtract one volume with another. Well, the difference here, and it gets a little tricky, the difference here is that there are some faces that get covered in surface area. Surface area is about what you can cover on the outside. And when you look at this object right here, I have a cylinder on top of a rectangular prism, and this part right here, this circle that's on top of the box, this isn't exposed as part of surface. This, you know, it's not covered as a part of the cylinder. I mean, it's covered with the box, and that part of the box is also covered as well. So the tricky part about this will be what we take away, because it's not actually a part of your overall surface area. I don't mind calculating the initial surface area of the cylinder and the rectangular prism, but the parts that we have to take away, the overlap that is actually not included in the stuff that we can see on the outside, is stuff we're going to have to take out. And you're going to have to follow with me the absolute best you can. But let's do one thing at a time. Let's find the surface area of the cylinder. I'll call it figure 1. Let's find the surface area of the rectangular prism. I'll call it figure 2. And then we'll subtract this area in the way we're supposed to. You'll see what we need to do. It gets tricky. Sometimes even myself, I got to talk through it to make sure that I know what to do. There's not one formula to it. It's however the drawing works. All right. So the surface area of both is going to be lateral area plus area of both bases, you know. So the surface area of the first one, we have to find the area of the base of the first one by doing pi r squared. Pi r squared, the radius is 4 feet. That's going to be 16 pi square feet. I think we still leave our answer in terms of pi. Oh, no, we round to the nearest tenth. But I'll leave exact answers as long as I can until I use the calculator. So then I round at that point. The lateral area of the cylinder here is going to be perimeter of base times height, the perimeter being the circumference, 2 pi r, and then times the height, which is 8, the height of the cylinder itself. So 2 times 4 is 8, times 8 is 64. So I'll get 64 pi square feet like that. Okay. So the surface area of the whole thing is going to be the lateral area plus the area of both bases, like that. And that's going to be exactly 64 plus 32 pi square feet. Now you don't combine these. This doesn't become 96 pi square feet. 64 doesn't have pi in it. As an exact answer, that's what it looks like. I'll round when I add these things up later when I need to. But I have to remember to take away some stuff in the end as well. In fact, one of these bases that I added should be taken away, but I'm just getting the gist of it, right? I just want to add these things up as if everything counted to start with. I hope you're okay with that. All right, let's find the surface area of the rectangular prism here. So now that's going to be 2. So the area of the base of this second thing, I'm going to call the bottom the base here. That's length times width, 14 times 8. And 112 square feet for one of those. Okay. The lateral area of the rectangular prism is perimeter of base times height. Now remember, there it's 14 plus 8 plus 14 plus 8. Perimeter of base times height, like that. 2 14s is 28, 2 8s is 16, 16 plus 28 is 44. 44 times 12, just leave it to the calculator. I don't want to screw this up. I ain't come this far. 44 times 12 is 528. So 528 square feet for the lateral area. So the surface area of the whole thing, let me box this one. The surface area of the whole thing there is going to be the lateral area plus the area of the 2 bases. 112 times 2 is 224. So 528 plus 224 is 752. There's no pi with this one, so yeah, these do combine. So there's a surface area, the second one, 752 square feet. So the surface area of the total, and this is a raw total because I still have to subtract something after. I'll show you what I'm going to subtract. But the surface area of the total, guys, I'm going to add these two up. I'm going to take 64 plus 32 pi. That's the surface area of one. Plus 752. That's the surface area of the second one. And here's what you have to subtract. This circle on the base of the cylinder covers the rectangular top, the part of the surface area of the rectangular prism. What that means is I need to subtract that area, but not just once. I need to subtract it twice. That area, that circular area, is covered on both objects. It's the bottom of the cylinder and it's on the top of the prism. That circle is not included on either, and it is included in both of these surface areas. So I need to take away, this doesn't work for every single problem, it depends on the problem. I need to take away double the area of that circle, and I know that it's 16 pi. I need to take double 16 pi away. Good news for us is double 16 pi is 32 pi. And when you add 32 pi and then subtract 32 pi, well, you don't have any pi left. That's gone. I didn't know that was going to happen. I should have thought about that, but there it is. So the surface area, the total thing is 64 plus 752, which I believe is 816. I'd love to check all my, answers and stuff. Just going through the logic, unless I messed up some weird math here, like I, didn't do this addition right or something like that. Unless I did some weird math somewhere, that's your surface area exactly of that whole thing, that composite solid, because of you subtracting that bit that we were referring to. All right, the circular base that exists in the cylinder and in the and on the prism, on the top. It's covered, so it doesn't count. It's not a part of it. All right. Last one here, guys, number 8. One more composite figure to go, and it's one of those, it's a hollowed out cylinder. It's got its square kind of cut into it, fitting a square peg into a round hole kind of thing. Let's deal with that. We'll think about what needs to be subtracted out from this thing. I'm even thinking, in those terms right now too. It's going to be messy. No. Sometimes it's not about subtraction. I'm thinking about that right now. Sometimes it's not about subtraction, right? Sometimes it's about other things. There are some parts that need to be subtracted, but we got to think about what this actual drawing really is. And I'll do the best I can to explain it. I'll tell you what, a net drawing is probably not going to help very much with this one, because the unfolding isn't really all that it's cracked out to be, because the outside isn't just the outside. There's stuff on the inside as well. All right. But I do have two objects. I'm going to start with those surface areas and lateral areas and all that stuff. Let's see if we can make sense of that stuff to begin with. I got figure 1. I got figure 2. Figure 1's a big cylinder. We see its radius of 14 feet. I don't know what that 14 has to do with. I guess it's that length right there. So radius of 14 feet for my first object. Okay, just so you know that's there. The area of the base is going to be pi r squared. So pi r squared, that's 196 pi square feet. The lateral area, perimeter, circumference, perimeter base times height. So the circumference is 2 pi r, 2 times pi times your radius, and then times the height of the cylinder. That's all. There are a lot of 14s in this. Times the 14. We just saw that was 196. If you double 196, you get 392. So that's going to be 392 pi square feet. So your surface area of the cylinder minus the cutout, thing here, the surface area there is going to be 392 pi plus 2 bases here, which is 196 pi. That's another 392, right? That's another 392 right there. So that's going to be 392 times 2, which is 784, I think, 784 pi square feet. All right, so that's the surface area of, I should be putting a 1 here, surface area of this cylinder. minus the cutout rectangular prism. Let's find out the surface area of the rectangular prism. And it is, once again, it's good to lay out all this other work because some of it's probably going to be used in some sort of capacity. You'll see what I mean. The area of the base, now we're talking about the rectangular prism here. It's a 14 by 6. So the area of the base, length times width, 14 times 6. 14 times 5 is 70, plus 4 is 84. So it's 84 square feet. The lateral area of the base is perimeter of base times height of the prism. Perimeter base is 14 plus 6 plus 14 plus 6. So 2 14s, 28, plus 2 6s, 12. 28 plus 12 is 40. So perimeter of base, I'll write it out. 14 plus 6 plus 14 plus 6 times the height. I think that was still 14, right? Yeah, the height of the prism is 14 right there. A lot of 14s. Did I say 40 before? So 40 times 14. 14 times 4 is 56. Times 10 is 560. So 560 square feet. You can see why I don't want to do 2 more problems after this. Sorry, you can't see it. 560 square feet. So I have the area of the base and the lateral area. The surface area, the whole thing. Honestly, I don't think I need the surface area, the whole thing, but I'm just writing it anyway. The surface area of the whole thing is 560 plus 284s. At some point, you might see me write that B is this and then 2B is that. I'll just write it straight up, but sometimes I write it inside the work here as well. 284. Let me do this. I don't want to screw this part up in the end. And honestly, I don't think I need this part. I do need those 2 times 84. 728. 728 square feet. Okay. I got surface area of the second one, surface area of the first guy. Now, everything else that's written out there, it's great. I'm going to need some of the stuff. Because here's what we need. We're not just going to add these two things up. Or, listen, we're not just going to subtract them either. What you need to understand with surface area is, literally, it's the area of the surfaces. Think about what the cylinder contains. Without the box cut into it, think about what the cylinder contains. There's a rectangular facing on the outside, because, unfolded. We talked about the lateral area. And then there's the area of the circles on top and bottom. Now, when we cut a rectangular prism out of the cylinder, you suddenly get an opening right here, that hole that is no longer a part of the area of the circle. The area of that rectangle, the area of that base, is no longer a part of the circle's area. So that has to be subtracted. And there are 2 of them. There's one on top and there's one on bottom. So those have to be subtracted from the cylinder's surface area. But here's the tricky part. Now that it's been hollowed out, you see these walls? You see that wall going down right here in purple? And this wall on the side and on the front and on that side right there? What would ideally be these 4, the lateral facings of your rectangular prism? Those are a part of your surface area. Think about it. That's on the inside. That's something that you'd have to paint or wrap or whatever. It's hollowed out. That's a part of surface area. That has to be added. That has to be added as a part of your surface area of your total thing. I know this is confusing, especially because I don't have a shape that shows it. I know that it is. The green is going to be subtracted. Your 2 bases of your rectangular prism are going to be subtracted from the surface area of the cylinder. But the lateral area of your rectangular prism, the whole thing, all 4, are actually now surfaces. They're sides that are inside of it. Those are going to be added to the surface area. So here's what I'm going to do for my surface area total. I don't know that I'm going to write it out without plugging in the numbers first. The surface area of the total will be the surface area of my cylinder. Take away the area, take away the area of both bases of my rectangular prism, but add the lateral area of my rectangular prism. That's going to be the final thing there. See, there's not one formula for these guys. It depends on the nature of the object and what's going on with it. Now it's a substitution, and here's the cool thing. I have all that information. I even have my 2B2. Oh, I don't, but it's right there. I have my lateral area 2. I have my surface area 1 up here. All of these are going to be used. Okay, so 784 pi, surface area of total, is going to be 784 pi minus those 284s plus the lateral area of the rectangular prism, which is 560. I'm going to end on this problem. And that will be, they said round to the nearest tenth, so I'm going to do it straight up right now. 784, you won't see this on my thing. 784 times, there's my pi button, times pi, minus 2 times 84 plus 560. Round it to the nearest tenth, 2855.0086. So 2855.0. 2855.0 square feet. 2,855 square feet. That is the surface area of the total thing there. Tricky. Very, very tricky. And it's a conversation to be had. I didn't even make net drawing would have been impossible for that hollowed out thing to make sense of kind of what's there. Excuse me, what's there and what's not. But labeling everything here along the way. It looks like I didn't need this. But labeling everything along the way is pretty useful for what it is that I'm doing there. Okay, guys, longer video with that one here. Whenever we're talking about surface area, it's bound to happen. You're going to, at some point, see surface area of pyramids and cones, and I think I'm going to make them separate videos, unlike what I did with volume at the time with pyramids and cones, because they were so much the same in what we were doing. These ones, the formulas, I like to get really particular with the cone surface area as its own different thing from the pyramids. Even the net drawing is different. Unlike these ones kind of have the rectangular unfoldings the same. Those are going to be different. So that ought to do it for this one, guys. I know you're going to have some questions along the way with this. If so, drop it in the comment section down below. I'd love to be able to try and answer as much as I can. But you know the video form is the thing that makes this thing best. But thank you if you paid attention to it. I sure hope that everything came to fruition in such a way that my explanation was important to make sense of how you lay out your work and how you can organize this whole thing. The net drawings, understanding perimeter base, circumference, and things like that can get a little tricky, a lot trickier than volume at least. And remember, you will be asked to find the volume in some of these, and the work that you do with areas of bases and such are really a part of what's needed. So it's not wasted work for you to lay that out and have it right next to when you do volume. That ought to do it for this one, guys. Thank you so much. This is Mr. Robinson here. Take care.